Find the equation of circle passing through intersection of x square plus minus 8x plus 4y minus 30 is equal to 0 and y is equal to 2x plus 5 having radius y. Something like this. Been given a circle and a straight line. Circle and a straight line is given. You are supposed to find out equation of circle. Let me change it little bit so that it is little easy first and then we will solve this. Instead of having radius root 5, I give you passing through 0, 2.
सर बहुत देखते इंटरसेक्ट होत नहीं है.
Intersect होता है.
Sir, how do we check if these intersect or not?
We will discuss. You can drop perpendicular from center onto the line and find out the distance of center from line. If it is greater than radius, it does not. If it is less than radius, it is. We know how to find out perpendicular distance. Recording. The first method by which we can solve this problem is method 1. It is simple. You find out, suppose this point is B, this point is C, and you have been given a point 0, 2, which is A. If you know all these 3 points, we know how to find out equation of circle. We have solved problem like that. Okay. So method 1 talks about getting coordinates of B and C. How do you get that? This is y is equal to 2x plus 5. Substitute back into this equation. Then you will get quadratic in x, which is x square plus 4x plus 3 is equal to 0. If we solve, we will get 2x coordinates. One of this point, another of this point. So x is equal to minus 3 and x is equal to minus 1. These are the two x coordinates of B and C. Corresponding y coordinates we can find out. Having got all 3 coordinates, which are minus 3, minus 1, that is B, C is minus 1, 3, and A is 0, 2. We know the procedure to find out the equation of circle. Method 1. Method 2. Let equation of circle be x square plus y square plus 2gx plus 2fy plus c is equal to 0. If we could find out g, f and c, our job is done. So if I put this, is point A on this circle? Yes. Put x is equal to 0, y is equal to 2. You will get one equation in G, F, C. One equation. If you put minus 1, 3 in this equation, you will get another equation G, F, C. Another equation. If you put minus 3, minus 1, you will get one more equation G, F, and C. So if you have 3 unknowns and 3 equations, we should solve it and then get value of G, value of F, and value of C. If we put these values back into this equation, we are done with equation of circle. Both these methods are little long. They will require a lot of calculations. And therefore, the third method which I am trying to tell you is most elegant, very less calculations, and most versatile. Method number 3 that we will discuss now is going to be useful for finding out equation of a sphere passing through the point of intersection of a line and sphere having radius something, or having, this is a sphere, this is also a sphere, and you have been given, so you can extend your geometry from two-dimensional geometry that we are learning now to higher dimensions using method 3. Using method 1 or method 2, it is going to be extremely difficult to deal in three-dimensional coordinate geometry and find out equations of spheres passing through intersection of a line and a sphere. Difficult. This method will work there also, and this is more versatile method and has several applications. I am explaining it to you for the first time, therefore everybody is required to pay proper attention. How do we recognize whether given equation is equation of a circle or not? Suppose I write like this: ax square plus by square plus 2hxy plus 2gx plus 2fy plus c. This is general degree equation in x and y, where a is a constant, b is a constant, h is a constant, g is a constant, f is constant, and c is constant. There are 6 constants in this. Now, if I want to say that this equation is equation of circle, I have mentioned this in earlier lectures. Characterization of degree 2 equation to be a circle, condition a is equal to b and h is equal to 0. Right? So if a is equal to b, and if a and b not equal, a is equal to b and not equal to 0, then we can divide entire equation by a and get x square plus y square as a leading coefficients, leading terms. There is no xy term because h is 0. And then we have something like this over there. So that is what is the characterization of equation of circle. Do you remember having said this? So equation
Yes, sir.
of circle will look like this always. Okay. And if any equation is looking like this, it is going to be circle. Both ways it is true. Therefore, now what we will do is, we will play very easily. X square plus y square minus 8x plus 4y minus 30 plus lambda times 2x minus y plus 5 is equal to 0. What I am trying to do here is combine both these two equations and put them in such a way that will B satisfy this equation? Will point B satisfy this equation? Yes, because B is on the circle, therefore it will make this part of the equation 0. And B is on the straight line, therefore it will make this part of the equation also 0. Lambda is a parameter, lambda is a real number. So real number times 0 plus 0 is equal to 0, therefore B satisfies that equation. Will C satisfy that equation? Yes, because C is on the circle, this part will be 0. C is on the straight line, therefore this part is 0. And therefore LHS is 0, RHS is 0. C also satisfies this circle, this equation. And now let us look at this equation and check whether it is equation of circle or not. If I want to rewrite it, I can write it like this: x square plus y square plus minus 8 plus 2 lambda times x plus 4 minus 1 lambda times y minus 30 plus 5 lambda is equal to 0. It is the same equation I have written again. Now if I compare this equation with this requirement of circle, yes, this is circle. So what kind of circle is this? If I put different values of lambda, I will get different circles. Now, will all these circles pass through B and C? Yes, because B and C satisfy this equation always for any value of lambda. So this is the equation of a circle, or it is the equation of family of circles. How will that family look like? Will this circle, we will get this circle by some value of lambda? Yes. For some other value of lambda, will we get this circle? Yes. For some other value of lambda, will we get this circle? Yes. For some other value of lambda, we will get this circle? Yes. So how many such circles are possible? Infinitely many. How many values of lambda are allowed to put? Infinitely many. Happen that for one value of lambda, I will end up getting two distinct circles? No. For one value of lambda, if lambda is equal to 0, is this the circle I am going to get original circle back? Yes. Is that the circle passing through? Yes. So this is the equation of circle, which is a family of circle. सगळ्यांचं मिळून एक इक्वेशन देऊन टाकलं आपण in terms of lambda. Now, amongst these infinitely many circles, which circle do you want? Oh, which passes through a comma 0, 2. Very good. So x is equal to 0 and y is equal to 2. If I substitute in this equation, I get value of lambda. If I put that value of lambda back into this equation, it is the equation of required circle. Using this method, check whether your calculations are less or not, and you get the final answer quickly without finding out coordinates of B and C. That is most important, because presently we have designed this problem where coordinates of B and C are good, because we are aware that you will go by that method and you should get good numbers. But one can design a problem where your B and C coordinates are extremely bad and you will get stuck in the calculations, final answer won't be correct. However, in method number 3, we are bypassing, we are not finding out B and C, we are directly finding out the equation of circle. So do the necessary calculations, get the value of lambda and get the final equation. Put 0, 2 in the equation, original equation, and get the value of lambda. These are the calculations. You get lambda is equal to 6 and hence you get the equation of circle like this. Okay. Just to confirm whether you have understood this method or not, let me give you a circle and let me give you a line. Now, one thing which I want to make it clear over here is, even if in two-dimensional geometry, if you have a circle like this and if you have a line like this, we will say that there are 2 points of intersection of this circle and this line, and those 2 points of intersection are imaginary. They don't intersect in real. So by method 1, if you try to solve this line simultaneously with this circle, you will get quadratic in x where discriminant b square minus 4ac is going to be less than 0. In that case, the line is not intersecting circle. but still we can find out family of circles passing through intersection. Maybe those are imaginary intersections, but through those imaginary intersections there will be infinitely many circles which will be passing, and we can find out the equations of those. That is algebra taking over geometry. Understand this. Let me see you all. This is algebra taking over geometry. In geometry, by seeing at objects, we say whether it is intersecting, tangent, or not intersecting. That is where we have limited understanding of geometry. Algebra says we use rules of algebra to figure out whether intersection is real, intersection is coincident, or intersection is imaginary. And the theory will continue to work. Theory will continue to be true. In that case, I mean, we will discuss this in detail in 11th standard. In this case, suppose this is the situation, circle and the line in real are not intersecting, and still I am asking you to find out equation of circle passing through some other point. Then those circles also will be, the family of circles will be like this. They will not intersect. The circle, family of circles will look like this. This way and this way. This side also there will be circles. This side also there will be circles. And no circle will intersect this line. All of them will keep some distance or the other. It is going to look like this. Do you understand? That will happen. These type of circles will have imaginary intersection. This line is not intersecting any of these circles in real. And therefore, whether you are doing it, whether you are cross-checking, I mean some of you cross-check whether this line is really intersecting this circle or not. You need not have to worry about it, whether intersecting or not. This theory will work and you will get an equation. And which is going to be correct equation. Because it is going to pass through the points of intersection, real, coincident or imaginary does not matter. So quadratic equation theory is hand in hand with geometry. This is where delta is negative. The diagram that I had made earlier, this one, when delta is greater than 0, two distinct intersection points, and the third would be two circles are tangent. Do you understand? If two circles, I mean, if a circle is tangent to a line like this, and if I ask you, find the equation of circle which is passing through points of intersection of this line L and the given circle S and passing through point P, something like this. But the line is tangent to S. So there are 2 points, but they are coincident. And therefore this center and the required center, they are going to be perpendicular to each other. Anyway, here also they are perpendicular. Here also they are perpendicular. So in this case, the family that you will get will look like this. All circles will pass through that point. And all circles will be tangent to line L. This side as well as this side. Do you understand what I am trying to say? This is delta is equal to 0. Algebra is delta is equal to 0 when you solve given lines simultaneously with circle. Delta greater than 0, two intersecting points. Solve lines simultaneously with circle. Quadratic equation has delta greater than 0. Its geometry is going to look like this. And if delta is less than 0, geometry is going to look like this. Doesn't matter. In every case, you will get the required circle. And therefore, now, the example that I am going to give, I am not bothered whether the line is really intersecting circle or not. I just throw some numbers. Worst come worst, you will have value of lambda rational value. That is fine. Eventually, you will get equation of circle which is going to be good. So, problem. question. Exactly similar. X square plus y square plus 8x minus 4y minus 7 is equal to 0 is equation of circle. And equation of line is y is equal to x minus 3. Point P is equal to 1 comma minus 1. Find the equation of circle passing through intersection of S and L passing through P. Let us see whether you can do it quickly or not. For recording purpose, what is the answer for this? Answer is x square plus y square plus bola
15x
15x
minus 11
minus
y
11y minus 10.
minus 28.
This is the equation. You get it using, now what is this method called? S plus lambda L is equal to 0. S plus lambda L, where S is the equation of the curve, L is the equation of the line. Okay. Now, okay, let me ask you a question where S and L, S and L, I am keeping same. Okay, S and L is same. Okay, and I ask you to find out equation of circle whose radius is root 5. Let me write down the problem again. Find equation, question, green, question. Find equation of circle passing through x square plus y square minus 8x plus 4y minus 30 is equal to 0, passing through intersection of this circle and y is equal to 2x plus 5 having radius root 5. Let me check whether you can apply yourself and get me the answer. Same story, write down, and we have already written it. X square plus y square minus 8x plus 4y minus 30 plus lambda times 2x minus y plus 5 is equal to 0. And then we have written the equation in terms of lambda also, this one, right? So what is the coefficient of x? 2f, na? So this is plus, okay, let me write down x square plus y square plus 2 inside bracket minus 4 plus lambda x plus 2 okay, so let me continue with bad calculations. Inside bracket 2 minus lambda by 2 y minus 30 plus 5 lambda is equal to 0. Now you have to stay with me. Whatever I am doing, you need to understand. This is what is the equation of circle. And G, this is my G value. This is F. This is C. Therefore, radius of family of circles in terms of lambda for different value of lambda, different radius will be G square. So minus 4 plus lambda bracket square plus F square, which is 2 minus lambda by 2 bracket square, minus c, that means plus 30 minus 5 lambda is equal to radius square, and now we have been given radius to be equal to root 5, therefore this is going to be 5. This should give us values of lambda. Let us expand and find out. 16 minus 8 lambda plus lambda square plus 4 plus lambda square by 4 minus 2 lambda plus 30 minus 5 lambda minus 5 is equal to 0, right? So how many lambda squares do I have? 5 by 4 lambda square. How many lambdas do I have? Minus 8, minus 2, minus 10, minus 5, minus 15. And what is the constant? Plus 16 plus 4, 20, plus 30, 50, minus 5. 45 is equal to 0. I hope my calculations are correct. Maybe if you clear the denominator and divide by 5 also simultaneously, then you will get lambda square minus multiplying by 4 upon 5, that is 12 lambda, multiplying by 4 upon 5, now 36. And this is lambda minus 6 bracket square is equal to, that is the unfortunate part. You were expecting 2 values of lambda, but you ended up getting only 1. That is lambda is equal to 6. If we put it back, we get the original equation which we had already found out. What is this geometry? This geometry is, you have a circle, you have a straight line, and then for every radius there will be 2 circles, one this side and one this side. But only one case you will have a unique circle. What is that case? When BC is a diameter. Okay, that is the only circle which is unique. Otherwise, if I draw a circle like this, exactly same radius, another circle will be other side. Now you need to understand this. Exactly same radius circle will be to the other side. Every time it will be 2. But this is the one. And maybe in this family of circles that we have written, this is the family of circles. In this, what is the smallest diameter circle? Circle with BC as a diameter. That is what this circle is. Whatever we have found out, x square plus y square plus 4x minus 2y is equal to 0. This is the smallest circle in this family. And therefore, if you cross check what is the distance BC, you had already found out the coordinates minus 3 comma minus 1 and minus 1 comma 3. Coordinate geometry is correct. Distance between them is 3 minus 3 plus 1 2 4 plus बरोबर येते ना, minus 3 plus 1 is 2 bracket square is 4 plus 16, that is the square of distance 20. 20 is 2 root 5, and therefore BC is a diameter, therefore it is 2 times root 5, and that is what is the circle. Therefore, those who have said that you have got 5 out of 10, I am wrong. It is 10 out of 10 because 2 circles are coincident. Now I just modify that and say find 2 circles having radius 5 instead of root 5. Calculations for radius equal to 5. Okay. Find equations. Bolo, yes.
Well, could you tell us the answer for this? question.
Answers. Yes, answer for previous problems are x square plus y square minus 4x plus 2y minus 20 is equal to 0, and x square plus y square plus 12x minus 6y plus 20 is equal to 0. Okay.
Thank you.
Yes. Now, suppose I give you a line y is equal to x plus 3 and a point on line 2 comma 5, 2 comma 5. Okay. Get me the equation of circle. Find equation of circle. Tangent to y is equal to x plus 3 at 2 comma 5 and passing through 0 comma 3. I wait for few minutes, then I tell you the story. Let us change the point from 0 comma 3 to 2 comma. You can solve this problem otherwise by finding out perpendicular bisector of 2 comma 3 and 2 comma 5, which is easy perpendicular bisector. And equation of line passing through 2 comma 5 perpendicular to y is equal to 4 x plus 3. Their intersection is going to be center. Okay. And from that center to 2 comma 5 or 2 comma 3 is going to be your radius. That is one way of doing it, which is correct, and it is also not very long. However, I would like to do it using S plus lambda L is equal to 0. And now, therefore, you pay attention. This 2 comma 5 is a point. I assume that point as a point circle. Circle with radius 0 and center at 2 comma 5 is a point circle. What will be its equation? X minus 2 bracket square plus y minus 5 bracket square is equal to 0. Right? So, in expanded form, the equation of circle will be plus 4 plus 25. This is my S. What is my L? Y is equal to x plus 3 is my L. Therefore, all circles tangent at 2 comma 5 will be x square plus y square minus 4x minus 10y plus 29 plus lambda times x minus y plus 3 is equal to 0. Every circle in this family is going to be tangent to this line at 2 comma 5. Now I want that circle which passes through 2 comma 3. Therefore I am interested in value of lambda. 4 plus 9 minus 8 minus 30 plus 29 plus lambda times 2 minus 3 plus 3 is equal to 0. So 2 lambda, how much is this? Minus 1, 4. 4 plus 2 lambda is equal to 0. 2 lambda is equal to minus 4, lambda is equal to minus 2. Therefore, equation of circle passing through 2 comma 3 is x squared plus y squared. Lambda is minus 2. So minus 2x minus 4x minus 6x. Lambda is equal to minus 2. Minus 2 minus y plus 2y minus 10x plus minus 8y. 29 minus 6. Is this the same? I hope.
Yes, sir.
Yes.
Is this elegant? Now, point circle. In geometry, we would not have imagined, or when I have told you that there exists a point circle, straight line is a circle with infinite radius and a center at infinity, etc. We think that it is not correct in geometry. Point circle, how can be a point imagined as a circle? But if I write the equation of that into two-dimensional geometry, this is the equation of circle. Is this the, now by looking at this S, quickly you will not realize that the radius is 0. And moreover, radius of the circle could be negative also. So there could be imaginary circles also. If you adjust your constant in such a way that your radius is negative, then those are the circles which will not exist in real. But the algebraic expression will be available. Okay?
So,
You understood this problem? Why? I mean, you are getting a family of circles. This equation for different values of lambda, you will keep getting different circles like this. Every circle will be tangent at this point. Because it is S plus lambda, satisfying S plus lambda L is equal to 0. So I did not have circle with me in this problem. I created a circle by considering this point as a point circle. And why it works is because the line is considered to be tangent to this point circle. Because both the points of intersection are coincident. Questions? Find the equation of line passing through intersection of 2x minus y is equal to 3 and x plus y is equal to 12 and passing through 5 comma minus 11. Let us change the point. This time also passing through 7 comma 2. You have found out 5x plus 3y is equal to 15 आणि 6. What is the 35 आणि 6?
sir, 39.
35 आणि 6 ना? हे बरोबर आहे का? 5x plus 3y.
Plus 2y.
Plus 2y.
Sir, 5x plus 2y.
3x plus 2y. 2y. So 35 आणि 4. 39. That is the equation. Show you how to do this using the previous theory. You must have found out the point of intersection and found out the equation of straight line passing through those 2 points. But now, suppose I don't want to find out the point of intersection. I say like this. 2x minus y minus 3 is my one line plus lambda times x plus y minus 12 is equal to 0. Now, ax plus by plus c is equal to 0 is a straight line. All terms linear or constant. This is a straight line in this x or y plane. So is this a straight line?
Yes, sir.
Because it is 2 plus lambda x plus minus 1 plus lambda y minus 3 minus 12 lambda is equal to 0. It is linear in x and y. So this straight line is suppose like this. This straight line is suppose like this. Then is this the point of intersection P satisfying this equation? Yes.
Yes.
Point P satisfies this, it makes it 0. Point P satisfies this, it makes it 0. So 0 plus lambda 0 is 0. Yes. So point P satisfies this, and it is an equation of straight line. Therefore, it is the equation of family of straight lines passing through P. All possible straight lines passing through P. How many of the straight lines I can draw? Infinitely many. How many values of lambda I can put? Infinitely many. 1-1 correspondence. If I put lambda is equal to 0, original line back. Okay. So for different values of lambda, you will keep getting different straight lines, and you want a straight line which passes through 7, 2. Oh, very good. So 2 plus lambda times 7 plus minus 1 plus lambda times 2, or it is better to put in the first equation. Let us put it. 2 into 7, 14 minus 2 minus 3 plus lambda times 7 plus 2 minus 12 is equal to 0. That gives us 9 plus 9 10 12 minus 3 lambda. Lambda is equal to 3. Is that right? If I put lambda is equal to 3, then I get the equation of straight line as 5x plus 2y paratriक 36, 37, 38, 39. Same as this. So theory works. This is not S plus lambda L. This is L1 plus lambda L2. I can change the problem and say given two lines same, and the next problem is find the equation of line passing through intersection of 2x minus y is equal to 3 and x plus y is equal to 12 having slope minus 4 by 3, because you have infinitely many lines here. So there will be a line with minus 4 by 3 slope. And now you are supposed to solve it using this, because otherwise also it is easy. But I am just trying to give you applications or importance of this method. It works for two straight lines. It works for circle and straight line. And in the remaining time that we are going to solve one more problem where it will work for circle and circle. S1 plus lambda S2 equal to 0. I will give you example for this, but meanwhile you just find out the equation of line. Maybe this is little longer method, but just to enjoy what we are doing is, this is our equation, right? And therefore slope is minus a by b minus 2 plus lambda by b, which is minus 1 plus lambda, which is equal to minus 4 by 3, right? Therefore, what is the value of lambda? Minus minus getting cancelled implies 6 plus 3 lambda is equal to minus 4 plus 4 lambda. Therefore, lambda is equal to 10. If I put lambda is equal to 10, we get the equation of line as 12x plus 9y minus lambda is equal to 120 and 123 is equal to 0. Reduce it by 3, you get 4x plus 3y minus 41 is equal to 0. Theory works. Next problem. Find the equation of circle. Passing through. Intersection of x square plus y square minus 4x plus 2y minus 20 is equal to 0 and x square plus y square plus 12x minus 6y is equal to 0 and passing through origin. नाही परत एकदा चूक करतोय मी and passing through 2, 3.
Answer.
Yeah, I mean that is what they are calling bad, but it's okay. See, now you are grown up, any rational, if it is really bad irrational, root of root, something like that, then it is bad answer. Square root of 2 is a very good answer. One has to be very fortunate to get the answer root 2 or root 5, root 7. They are not bad numbers, they are good numbers.
Sir, no means the denominator is 23.
Yes, if you are getting rational numbers, you should be very happy about it. They are not bad numbers. Anyway, x square plus y square minus 4x plus 2y minus 20, that is my first circle, plus lambda times x square plus y square plus 12x minus 6y plus 20 is equal to 0. Now let us observe, are the coefficients of x square and y square same? Yes. 1 plus lambda times x square plus 1 plus lambda times y square. Same. Is there any xy term? No. Therefore, S1 plus lambda S2 is also equation of circle. This is also circle. Rather than that, it is also family of circles. What is it? It is similar situation. You have been given two. Now I am drawing intersecting but need not be intersecting. Then passing through these 2 points of intersection, there will be infinitely many circles. Centers will be on the line joining. Perpendicular bisector of this segment. Geometrically, we understand this. All centers will be on this line. And there will be infinitely many circles. Maybe if they are intersecting, there will be a unique smallest circle. If they are the two kind of circles where they are not intersecting, then smallest circle is going to be a point circle. Anyway, that discussion we will do in 11th standard. But this is also family of circles, and you are searching for a circle which passes through this point. So if you substitute x is equal to 2 and y is equal to 3 in this whole equation, you get value of lambda. So this is the procedure. You put the family of the curves that you want in lambda form, put the geometric condition, restriction on that geometry, get the value of lambda, put the value of lambda back into the original equation to get the required curve. So you are saying that this is bad. So first bracket is 4 plus 9 minus 8 plus 6 minus 20 plus lambda. Second bracket is 4 plus 9 plus 24 minus 18 plus 20 should be equal to 0. So coefficient of lambda is 14 28 आणि 38 58 वजा 18 40 9 आणि 1 10 4 आणि 1 5 आणि मायनस 14 मायनस 9 करेक्ट आहे लॅम्बडा इज
Sir,
Yes.
it should be 39, right?
Yes, sir. 39.
Yes, sir.
this is 39
39.
okay 39 so this is the lambda value. Are you getting this value lambda?
Yes, sir.
9 upon 39. So that is not bad. You can put, I mean, the easy way to go about it is write 9 here and 39 here. Because if you multiply throughout by 39, RHS is 0. Therefore, 39 here and 9 here will give you the required equation of circle. So today's topic was S plus lambda L is equal to 0, L1 plus lambda L2 equal to 0, and S1 plus lambda S2 equal to 0. This is the new tool that I have taught you today. You need to search for applications now. I think in the problem set that is pending with you, there will be a couple of problems which can be solved using this method. Now you search whatever difficult problems you are saying, maybe 1 or 2 of them can be solved using one of these 3 methods. Okay, and let me tell you which problems which you should not solve because they are really bad numbers. I have checked with my other teachers, and problem 28 and 29 not solve, and remaining problems you should keep trying and keep checking which ones are difficult. On Thursday lecture I will clear all your doubts. Is that thing very clear to you? Is it clear?
Yes,
Sir,
sir.
do we have lecture tomorrow?
Yes, we have lecture tomorrow at 7 o'clock.
Sir, question 28 and 29 from which lecture?
No, from the question set which is given to you right now.
Sir, for tomorrow, what homework?
Tomorrow you solve 10 more problems. From today to tomorrow you should solve at least 10 problems. And check whether whatever you have not solved yesterday, so can you solve using this tool. I think there is one problem with this tool which you can solve.
So what about the doubts question 1 to 30?
Yeah, that is what I am saying. On Thursday, I am not going to teach you anything new. Clear all doubts and solve additional problems. Because I am hopeful of you able to solve those difficulties having gone through the theory required for that. Angle bisector, etc. we have not done yet. We will do it tomorrow.